in the browser world, you often hear people talking about the browser DOM and DOM manipulation and so on. In the React world, you often hear people talking about the virtual DOM. What exactly is the virtual DOM and how is it different from the browser DOM? And why do we have a virtual DOM? Similarly, if you learn about Vue.js, there also people mention about the virtual DOM. Let's learn a little bit about virtual DOM and why is it interesting in a React application. Before we talk about virtual DOM, let me again reiterate that the browser DOM is a browser object. And so when you render something in your web page, the browser DOM is built up, and so any changes that you want to make to your web page will be affected when you make changes to the browser DOM. Now, in the React world, the React application maintains a virtual DOM. The virtual DOM is a React object. The virtual DOM in React's terminology is a lightweight representation of the browser DOM. Now, since the virtual DOM is an in-memory object in your React application, the virtual DOM can be easily manipulated by React whenever it requires. So manipulations are extremely fast compared to manipulating the browser DOM. When you change anything in the browser DOM, you need to go and re-render the web page all over again. But the virtual DOM, since it is maintained in memory by your React application, you can easily make changes to the virtual DOM. So when you have any changes to the state of your components or changes to the props that a component obtains, then that may result in the component being re-rendered. So this re-rendering is initially done to the virtual DOM. So any changes are reflected in the virtual DOM first, and then after that, we will see how the browser DOM gets manipulated. Now, so this virtual DOM is created completely from scratch every time you call the set state. So you see that whenever you call set state, you are changing the state within your React application, which also means that it is possible that some of the props passed into the child components will change, and so the child components may have to be re-rendered. So in your browser, in your DOM hierarchy that you build up, the virtual DOM hierarchy that you build up in your React application, not all components may get affected by changes to the state of your application. So as an example, on the left side, I show you a virtual DOM tree here, and in that virtual DOM you see I have marked 3 components there with red color. These 3 components are the ones that have been affected by a change in the state for my React application. Now what that means is that you will have to re-render your view in the browser. Now that means that you will need to manipulate the browser DOM to make the browser DOM correspond to the changes that have been effected in the virtual DOM. So the way React applications work is that they will do a difference between the previous version of the DOM and the current modified version of the DOM. So to notice which parts of the DOM tree have changed or the virtual DOM tree have changed, then you know which of the components need to be re-rendered. So in this case, for example, when these 3 red components are affected due to the change in the state, then it may result in re-rendering of all those nodes that are marked in purple to the right of this screen. So only that part of the DOM tree may have to be re-rendered to ensure that the changes are reflected into the browser DOM. So how is this actually done? Now with React, because React maintains the virtual DOM, which is a React object, and as we understood, manipulating the virtual DOM is very, very fast and effective. So every time there are changes to the virtual DOM and you are at the point of re-rendering the view in the browser DOM, then to update the DOM, React runs a diffing algorithm. The diffing algorithm will detect all the nodes that have changed. And so once it detects all the nodes that have changed, as we have seen, the red colored nodes that were marked in the tree there, and then this may result in updates to the entire subtree if the diffing detects that the two elements are of different types. So the diffing algorithm identifies the minimum number of components or the minimum part of the tree that needs to be updated in order to make the modified version in sync with the browser DOM. Now, when you are rendering multiple items, for example, in a list, you can use the key attribute in the list items in order to indicate which child elements are stable. Indeed, that is the reason when we rendered lists, we always applied the key attribute to each list item, and each key attribute was a unique identifier for that particular item in the list. So when the diffing algorithm works, if it notices that some parts of the list have not changed, they don't need to be re-rendered. And so it will re-render only those list items that have actually been modified. Now with React 16, there is a new version of the React diffing algorithm called as React Fiber. This is the new reconciliation algorithm that has been launched with React 16, and it is a lot more faster in performing the diffing and then identifying what needs to be changed in the browser DOM to update the views. With this quick understanding of what the React Virtual DOM is, let's move on to learn more about how to make use of the React router in this lesson.